In our previous lessons, we have gone through series of ways to be able to look at how we can draw graphs of parabolic functions, which are also known as quadratic functions. My name is Nanaya Wedu, and you can call me Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In this lesson, we want to solve a question. We want to use a question to be able to revise on what we have looked at on functions, specifically on linear functions and parabolic functions. We want to see how real and how important these functions are to our real life. So let's consider this question. So the question says that, right, a local electronics store is selling a new smartphone model, right? The store manager has recorded the number of smartphones sold and the corresponding price for each week. So the data is as follows. So in week 1, the price is 800 Ghana cedis and the number of smartphones sold is 30. For week 2, the price is 700 Ghana cedis and the number of smartphones sold is 40. Week 3, the price is 600 Ghana cedis, the number of smartphones sold is 50. Week 4, the price is 500 Ghana cedi and the number of smartphones sold is 60, right? Now we are to construct a linear function that represents the relationship between the price P and the number of smartphones sold N. And then we use that to predict the number of smartphones that will be sold if the price is reduced to 200 Ghana cedis. Now, there are several ways of solving this. There are several approaches to solving this. So we are going to consider different approaches whilst we move on in different lessons. So in this lesson, we want to consider our first approach, right? So in this approach, we are going to use the gradient and then the equation of the line to be able to solve this. So let's look at how we can solve this. So to be able to solve this, we must actually basically be able to put what has been given to us in terms of the number of weeks into a table. Let's use a table so that it looks nicer. So let's put weeks and then the number of phones that the person was able to sell into a nice table. So we have the first part representing the week, right? And then the bottom part representing the number of phones that have been sold. Okay, that's fine. So it means that we are going to have the week, right? So we can have week 1, we can have week 2, we can have week 3, and then we can have week 4, right? And then in our next one, we'll have the price. And then in week 1, the price was 800 Ghana cedis. So write Ghana cedis here. And then week 2, it was 700 Ghana cedis. And then it went to 600 Ghana cedis. And then 500 Ghana cedis. Let me include one line where we would indicate the number that was sold in each of the weeks. So in the final part here, we are indicating the number. So we have the number of phones, right? In this case, number of phones sold. So the first week, the storekeeper sold 30 phones, right? The new smartphone. In the second week, he sold 40. In the third week, he sold 50. In the fourth week, he sold 60, right? So we have our table nicely drawn here, right? So we can clean that side. So in that approach, what we are going to do is that we are going to consider the equation y is equal to mx plus c, right? So here we can say that the y will now be n, which represents the number of phones sold, right? And we know this is the equation of a line. And then the x will be equal to the p, which represents the price of the phone, right? So we can say that n is equal to mp plus c. Okay, that is right. So now we can approach it by looking at picking 2 points. So we want to pick 2 points. So we can pick the first two. So 1 point is 800 and then 30. And another point is 700 and then 40. And then we know that finding the m, which is the gradient, is equal to y2 minus y1 all over x2 minus x1. So we can label these points as x1, y1, s2, y2. So it means that our m will be equal to, right, y2 is 40 minus y1, which is 30, all over x2, which is 700, minus x1, which is 800. So that means that our gradient m is equal to 10 all over negative 100. So that means that our m is equal to negative 0.1, right? So it means that we can have our n to be equal to negative 0.1 p plus c. Now we can pick any two values of n and p. So probably let's pick 605. So we need that our n is equal to 50, right? 650. So our n is 50 and our p is 600. And then we substitute that into the equation here to find our c. So it means that we are going to have 50 to be equal to negative 0.1, right, multiplying p, which is 600, plus c. So when we have negative 0.1, right, multiplying 600, that is going to give us, right, so negative 0.1 multiplying 600 will give us negative 60, right, plus c, and this gives us 50. So that implies that we are going to have our c to be equal to 50 plus 60. So it means that our c is equal to 110. So we can therefore now write our equation, right, or our modeled equation, or our linear function that we have been asked to construct. We can write it as, in this case, we have our n, right, which you already know now. Our n, right, is equal to negative 0.1, right, p plus our c, which is what? 110. Right, so we can write it as a function in this form. So we can say that n of p, right, the number of the phones in respect to the price, is equal to negative 0.1 p plus 110. Okay, negative 0.1 p plus 110. So this represents the function. Now in the question, we are saying that if the price is reduced, so price, which is p, is reduced to be equal to 200 Ghana cedis, right? So 200 Ghana cedis. Then how many phones will the storekeeper be able to sell? So it means that wherever we see p, we'll put 200 there. So our n of p, which represents the number of phones, will be equal to negative 0.1 multiplying 200, right, plus 110. So it means that we're going to have negative 0.1 multiplying 200, right, plus 110 to be equal to, right, so n of p will be equal to negative 20 plus 110. And in that case, n of p becomes equal to 90. So it means that we can say that 90 phones, right, will be sold if the price is reduced to 200 Ghana cedis. So this question tells of a real world, how we can approach, right, the linear functions, or how we can model our businesses using linear functions. In this case, we see that the more you reduce the price of your item based on the storekeeper's, right, price and the number of goods that are being sold, the more you reduce the price of your item, the more number of phones that are actually sold. So if you can get probably a little amount of profit, it will be good to reduce your item so that it goes quickly, and then you can go and buy new ones. So in this lesson, we have basically used a question to revise on linear functions. In our next lesson, we want to consider the inequality graphs, right? Or we want to consider graphs of inequalities. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.